All right, so now we move on to compound events for probability, and this is by far the hardest probability that we can do because there's a lot of conditions that we could have. First, we're going to do mutually exclusive and overlapping events. So if they're mutually exclusive, that means they cannot happen at the same time, and if they're overlapping, that means they could happen at the same time. So A says, what's the probability that you spin a 2 or a 5? And we all know that you couldn't be a 2 and a 5, so that's going to be mutually exclusive. And I'm spinning a spinner with equal size portions numbered 1 through 20, so that's a fair probability. So when we do have mutually exclusive, we are going to, and it's an or probability, we're going to add the two probabilities. So the probability of a 2 or a 5 is going to be the probability of a 2 plus the probability of a 5. So that's going to be 1 out of 20 for the probability of a 2 plus 1 out of 20 for the probability of a 5, and I get 2 out of 20, which is 1 out of 10. Then, if you'll look at the next question, the probability that you spin a multiple of 2 or 5, they're talking about multiples of both of them. So that's going to be, now, what are the multiples of 2? 2, 4, 6, 8, 10. And then what are the and then it keeps going. And then what's the multiples of 5? 5, 10. You see how 10 is in both of them? So those do overlap every now and then. So that's going to be the probability of a multiple of 2 plus the probability of a multiple of 5 minus the probability of a multiple of 2 and 5. So the probability that it's a multiple of 2 is, there's 20 numbers, that's going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That's 10 numbers, so it's 10 out of 20. So I'm going to replace multiple of 2 with 10 out of 20. And then the probability that it's a multiple of 5 is 5, 10, 15, and 20, which is 4 out of 20 total numbers. And then the probability that it could be both is 2. 10 and 20 are both multiples of 5 and 2. So we're going to subtract 2 out of 20, and we get 12 out of 20, which is 3 out of 5. All right, moving on to independent events. Independent events are where the outcome of one event does not affect the other. Like if you have 2 dice or 2 different spinners or 2 different hats that you're pulling stuff out of, those are independent events. So if you need to find the probability of A and B, you multiply the two probabilities. So I've got a red number cube and a blue number cube. What's the probability that I will roll a 3 on the red and an even number on the blue? So that's going to be the probability of a 3 and even. So it's going to be the probability of a 3 times the probability of an even. So the probability of a 3 on a number cube is going to be 1 out of 6. And I'm going to write red above that one and blue above this one because they are 2 different number cubes. The probability of an even on the blue number cube is 3 out of 6, which is 1/2. So if you multiply them, you get 1/12. So the thing you need to remember is the reason you multiplied them is because it said and. Okay, you roll a red number cube and a blue number cube. What's the probability that you roll 5 on the red and a 1 or 2 on the blue? So a red number cube, the probability of a 5 and 1 or 2 on the blue is going to be the probability of a 5 times the probability of a 1 or 2. So the probability of a 5 is going to be 1 out of 6. And the probability of a 1 or a 2 is going to be 2 out of 6, which is going to be 2 out of 36, which is 1 out of 18. All right, then let's say you have a certain set of things like these mahjong tiles here. Sometimes they'll ask you, what's the probability that I pull a dragon tile and then a flower tile? You need to know, well, am I replacing the tile I pulled first or am I putting it back? So the first thing we're going to talk about is if you're replacing it. And if you are replacing it, they have to tell you that you replaced it. So this question says you replace the first tile and then choose again. So in that case, it's easier. So what you're going to do is first figure out what they're asking you. What's the probability that you choose a dotted and then a dragon? So the question is, what's the probability of a dotted, then dragon? So first you're going to find the probability of a dotted tile. So that's going to be, if you'll look, there is 4 dotted tiles, and then there's 3 by 5, which is 15 total. So it's going to be there were 4, weren't there? 4 out of 15. And then you're going to find the probability of a dragon. So if you'll look and count, looks to me like there are 3 dragons. And then again, I put the tile back, so there's 15 total. So that's going to be 1 out of 5. And then your question was I needed to pull a dotted and then a dragon. So since I had replacement, my probability is going to be dotted and dragon, which is going to be the probability of a dotted times the probability of a dragon. So 4/15 times 1/5, and I get 4 out of 75. So this is not your guided question. It says, what's the probability that you randomly choose a bird and then, after replacing, see, they have to tell you replaced it, a flower. So a bird, so that's going to be probability of a bird times probability of a flower. So it's going to be a bird probability is 2 out of 15. Probability of a flower is 1 out of 15. So that's going to be 2 out of 225. Okay. Okay, these are your got it questions. Make sure you do them on a separate sheet of paper. You've got 5. Number them 1 through 5. I don't have mine numbered, but don't use these numbers for sure. Number them 1 through 5. If you have any questions, you know how to get in touch with me. If not, I'll see you tomorrow.